What we want for today, our goal, or my goal, is for all of you really understanding the step code metrics, really understanding the compliance report, and then we're going to talk about this in detail and some of the challenges we've seen as energy advisors. I'm not an energy advisor myself, but we manage a bunch of energy advisors and working with local governments and understanding the step code. There's things that are evolving in the step code. When we talk about the metrics of the step code, we're really going to talk about how we see them in this house. So what makes up each of those metrics in this house? And what are you seeing on this compliance report right now? If a builder comes in with this compliance report so that you can see this, read it, and understand it, and know how to ask the right questions as you need to when you're looking at a house and you're walking through it, so that you look at this report, you're looking at the house, and it all makes sense. That's the goal. The Township of Langley has adopted the BC Energy Step Code, starting with Step 2 for the inside the development permit areas, and Step 1 for outside the development permit areas. And then it has a progression as it moves forward into time to 2022. And as we understand, there'll be consultations with builders to seeing how it's going over this next couple of years in terms of where you may go in the future with the step code. We'll go into detail about what each of these steps mean and how we see this house right here in terms of the steps. The Township of Langley has had an incentive program over the last few years aligned to the BC Energy Step Code that provides incentives for energy modeling, mid-construction blower door testing, and then financial incentives for building to the upper steps of the step code, so Step 4 and Step 5. The Township of Langley has also created its own form. There is a provincial form that's very similar. Look at this one. The Township of Langley has decided to develop its own form. It's slightly different. We'll point out the differences, and we will look at some of the differences in the provincial form too, so you understand a few additional elements that are in the provincial form that aren't in the Township of Langley form. And again, what we're really going through today is going through each of these components and linking it to the house so that we understand how we can read and understand this, and why there might be some differences when you see from the plans that a builder may give you and the energy modeling report that the energy advisor will give you and on this compliance thing. There may be some important differences, and we'll talk about why. At a really high level, I want to just talk about what's the vision and purpose of the BC Energy Step Code, because I think it builds the context for what we're talking about today. It's a performance-based approach. So we're moving away from the prescriptive approach, so the checklist approach that said this much insulation in the attic, this much in the walls, these types of windows, all the things you would usually have done in the past. We're moving sort of completely away from that. Although this is still a good guideline in terms of what the code's supposed to build to. Builders may do very different things. Now the process is that there's a consultation between an energy advisor and the builder. They look at the plans. They build an energy model, and then there's a post-construction blower door test. We'll talk about today about mid-construction blower door tests and the importance of that, and really about the importance of airtightness. And if you don't meet the airtightness target, and many is how you can basically fail on the BC Energy Step Code, and you may be at a point of no return. So we'll talk about how we can get there and make sure when you come at the final as-built stage, one does not have to reject the occupancy permit. What the energy advisor does, they take all kinds of information about the home. They look at the size and shape of the home. They look at the R values, the RSI values. Look at all the mechanical systems. They look at all the site information, including where it's located, climate data. They talk about what type of air leakage the builder might achieve, and they put that into the energy model, and then they come out with the step code metrics. So it's also a voluntary compliance option. So it's voluntary in the sense that any local government can decide to adopt the BC Energy Step Code. They can make it a policy, but they're not required to do so. It's also voluntarily available by builders to adopt it. We have many builders across the province that are building to all levels of the Step Code, and they're just deciding to do so. And communities can adopt it, and we're seeing some adopt it in all kinds of different levels, many starting with Step 1 or 2. As soon as a community does adopt it, then it's not voluntary for the builder anymore, it's a requirement. This is where we're sort of going nationally. So the federal government said by 2030, the building code's going to a net zero ready home. And what net zero ready means is that home is built energy efficient enough that more or less with renewable energy like solar panels or other sorts of renewable energies, it would be able to generate as much electricity as it's using in a year. And the timeline for British Columbia is 2032, we're always a couple of years behind the federal and the code. So that's really not a very big time frame to completely change really how homes are being built, because a net zero ready home is going to look very different. So why the province of BC has done this is said we need transition time. We need to start ratcheting up step 1, step 2, step 3, so that by the time 2030 hits, builders are ready, and consumers are probably more ready by understanding what high performance homes are. And this is what it is. A StepCo is a pathway to net zero ready construction, and it starts with steps. the lower steps and the higher steps building up to there now. And while we already have lots of builders building the step 5 now, it's not really common. And it is more expensive to build to that level. So what the intent and hope is that over time, as builders adjust their building strategies, they will be able to increasingly build to those higher steps affordably. What's really important to note is that the first step is about enhanced compliance. So step 1 is basically a home that performs as well as or better than a building constructed to the minimum prescriptive requirements of the code. Sometimes we've heard like, well, the step code, this is just radically changing everything. It's going to be a completely different home. For step 1, it shouldn't be a completely different home. For step 1, it should be a home built to code that's been energy modeled and verified that the energy efficiency requirements are being met. So it's also meant to be a consistent approach to advancing energy efficiency in buildings. In the past, there have been many different programs. There's Built Green, Energy Star, R2000, LEED, and local governments had adopted different programs, and builders often said, well, this is my requirement in this place, it's something different somewhere else. They all measured sort of energy efficiency differently, so maybe needed different certification. And it was really impossible for anyone to know which of these two homes was actually more efficient than the other because they measured it differently. They had different requirements. So the intent of the BC Energy Step Code is to give a common standard and allow local governments to have a program that they could adopt that was market neutral. Builders can still build the Built Green to Energy Star to LEED to whatever they want to in addition to the step code, right? But a local government shouldn't really be choosing winners between programs. It should be adopting a market neutral approach, and builders can build to whatever they want to. The step code is also a series of measurable energy efficiency targets. So we'll talk about these in detail now. What it does is set an energy performance metric for air leakage, for mechanical energy use intensity, and thermal energy demand intensity. But the key element in what we see in this building is that it's really a focus on the performance requirements of the building envelope. It sort of forces a builder to think about the building envelope. In some of the past programs, you could hit a target just by putting in a high efficient heating system. The intent of the step code is really just, the meaning is that, heating systems come and go, but your building envelope sort of should be forever. So the step code metrics really focus and force a builder to put things like this in, focusing on the building envelope. So it also offers the builder a lot of flexibility to pursue different options. They're not really tied to the prescriptive requirements of the code anymore. It's not saying put this much insulation here, these types of windows there. What it says is there's no fixed recipe, there's lots of options to meet code, step 1, and all the other steps. There's many, many different options. And that your consideration might be the step code target. It might be the builder preferences. The builder might go, I know how to build this way really well, so we're going to focus on that. We can do it really cost effectively. It might be what their clients want. Maybe their clients want more windows on a south-facing part of their home that has ocean views that might really negatively impact the efficiency of the home, but as long as the builder and the designer can figure out how to make that home efficient enough to meet the step code requirement, then it's fine. You can do that. You just have to do other things to make sure the overall building energy performance meets the target. Now, and generally we're wanting to see homes that are at least built to the energy efficiency requirements now and better, but it could be that someone's doing something else, doing something that doesn't meet code now, but does other things. So it's also a standardized reporting process. And what we see with the form you have in your hand and the provincial form is that as long as this is completely and accurately filled out, that shows that they meet the requirements of the code. There wasn't this type of thing in the past for people to verify the energy efficiency requirements of the code, and that's why these forms have been created. And it's also a tool for consumer and industry protection, the step code. So, we've heard in the past that, there's builders that build all types of different homes and maybe not meeting code at all, but, they're sort of able to get away with it. So from industry of builders, they want to say, great, I'm competing on a level playing field. I am actually investing in the energy efficiency of this building. Here's how I can prove it. It's not just saying this has, Energy Star appliances and, good windows, and that's it. Which, as you would see on many advertisements for homes, that's all they sort of say. That's an efficient home. That's not an efficient home. What an efficient home is, well, how do you verify that it's an efficient home? And that's what the step code does. In terms of consumer protection, over time, as people become familiar about the step code and energy efficient homes, they'll be able to choose or ask for a home and say, I want to buy an efficient home. And they could say, well, I want a home built to step 3, 4, 5. And over time, consumers right now, which have a very low level of understanding, will come to understand this and be able to ask for that. And or be able to compare just like they would other things. Well, based on location, number of bedrooms, well, what step code levels is built to? Well, that's sort of what the step code's about. It's sort of taking us to that 2032 stage in BC. It's ratcheting it up slowly over time that allows builders to adjust and change their building practices and to start to understand the things that are important to the step code. What does the step code measure? Again, it measures the performance requirements of the building envelope. So we're talking about, the windows, walls, the insulation, equipment and systems. So we're talking about heat and hot water and ventilation, and really importantly, airtightness. When we look at the compliance reports, if you know the Township of Langley building permit application checklist, what builders needs to bring in is the pre-construction form, the Underguide report, and the energy modeling report, the HOT 2000 report. So you might be seeing these documents coming in. And additionally, the township are requiring is for the air barrier details to be on the drawings. So that in red, that the air barrier details would be all around the building completely. And the intent of that is, one, for you as building inspectors to know that the designer and builders thought about that. As we hear many, many cases where people just don't think about the air barrier on parts of there was examples given in the last workshop that, often over garages, that people really aren't thinking about that. Like if there was a garage that came underneath the house, people aren't thinking about the air barrier there. Also an important place because someone's starting their car up underneath there and there's exhaust, but it's also important for the energy efficiency purposes. So there's multiple benefits of an air barrier. But if you haven't planned for it from the beginning, it's likely that it might not happen. So whether safety and energy efficiency concerns, it's also meant to change the process over time by making this requirement so that the designer's thinking about that right from the beginning. And if they're building a different type of home, they need to think about, well, what type of air barrier approach am I going to use? If we look at the Underguide report, what it shows you is the Underguide rating, and this is the Underguide rating for this home. So it's 81 gigajoules a year. It shows you the rated greenhouse gas emission reductions, 1.4. So for a larger size home, this has a very low greenhouse gas footprint. It shows you where the energy is used in the home. So we can see here that, for example, space heating is 36%, space cooling is only 3%, water heating is 22%. It also, on further pages, also provides all kinds of details about the building envelope. So when you're looking at this characteristics page in the center row where it lists the building envelope elements on it, you can also check that on this report. And what you would want to see on this report is that there's certain elements that match, and we'll go through what should match between these two reports. The HOT 2000 report is a much longer, not as visually appealing report, but has a lot of data in it. Basically, this report has all of the information that's in the energy model, or most of it, printed. So general housing characteristics. It's about probably 4 pages long of all the window characteristics. So it shows every single window, what that window is, every single window, the window schedule for everything. It would also have information about the air leakage, the F326 ventilation requirements, all the details about space heating systems and various things. So when this report comes into your office and you want to check, you have the plans, you have this report, and you have these documents. You can check that if you're wondering, this report doesn't seem quite right. Why is it the step code metric? Why are you not passing? Or why are you passing and it seems better than it should be? You can check that all this data would be correct. It should match what's listed in this document. In this Township of Langley BC Energy Code Step Code Bulletin, what it really talks about is the consistency of the information between the drawings and the energy model. So you have the drawings the builder provides you and the energy model. It should be consistent. And that along the way, this is really important, that as things change, as they usually do in building projects, the energy advisor should be informed, but any changes that are made along the way should be identified, and on the report you get when the home is built, it should be listed on there. So on the first page of the report, obviously a building permit number identifies Mr. Larry Clay and his company here, the address, the legal description, the climate zone. Climate data for Township of Langley should be listed as Abbotsford. Again, if we took this home and put it in Fort St. John, you get a different step code metric. You can move this house and is its model across the province. That would impact the energy performance of the home. Obviously, there's more heating and cooling degree days in different areas depending where you're located. It also on here lists the modeled floor area of the home. So this is a really useful if you were wanting to validate some of the step code metrics. By knowing the heated floor area, you can do a quick math double check on some of these numbers, and we'll sort of point that out later. So that's a really important one, just as a good piece of information to know how large the home is. But second, it's good to know if you wanted to validate some of these numbers in the report. This also identifies that this home will have a secondary suite, as there will be a secondary suite within the building. The building characteristics part, it's meant to be a summary. So while in the HOT 2000 report, there might be 10 pages that outlines all of the building envelope characteristics. Here it just lists less information about what the exterior wall is, what the floor headers are. And this information in the middle is what should match the plans. If you're looking at the RSI values, what's on the actual plans, what's in the report, very likely will be different. And that's because when the architect does this, they use some sort of, code generalized assumptions about the RSI or I value assumptions. They use a sort of a chart that says, well, this wall assembly is going to have this RSI on it. But what the energy modeler and the energy advisor does is take the complete wall assembly and rebuilds it, does the whole geometry of the home, knows how many corners there are. So it would take all this information and then put it into a computer model, which was going to look at the heat loss through the corners, for example. So if you have a corner with a lot of lumber in it, that's going to have a lot more heat loss through that wood than you would have in a section of wall like this, for example, or any other place. So the energy advisor uses very specific information in an energy model to generate what the RSI values are. So they will not match. So if you were looking at the plans and it showed RSI value and you looked at this part right here to see SRI value, they'll likely not match. And that's not a problem. What should match is this information here, because what you want to know is that the energy advisor had the right information about, for example, the foundation walls and slab. If that's different, then something's probably wrong, because the energy advisor has the wrong information in it. The information in the brackets is R value. So if we look at the top one, it's RSI 4.43, just for reference in the brackets. These step code reports will always be in metric, but if you're interested in R values, it's, RSI 4.43 is 25.15. Also, when you're looking at this report, when it lists windows and doors, and it lists the FDWR, the ratio of total vertical fenestration and door area to gross wall area as a percentage, like how many windows there are over the vertical wall thing. This information might not also match the plans or the HOT 2000 data, because the HOT 2000 data may include skylights in it as well, which is not part of the vertical fenestration. So this is an area that might not match as well. If you're looking at a HOT 2000 report and you're looking at that, it may not match. So it's important to know what might not match when you're doing the check or understanding the data between the various pieces. This is the ventilation type. This is an element that's on the Township of Langley report, but not in the provincial report. It's listing that the HRVs meet the BCBC minimum. So this should be listed on here, and 56 liters per second. The assumption in HOT 2000 is based more on the federal thing, so it could say something different, but that's why the energy advisor has been asked to note this here and make sure that's correct. Now in this chart right here, we're going to go through part of the balance of our presentation, and this is really your executive summary that would say, are the step code design requirements met in this home or not? Hopefully you're seeing yes here. It may be when the first time an energy advisor gives this back to the builder, after they've seen the plans and talked about this, on many occasions it might be no. They would give a draft of this back and they'd say, nope, you don't meet one of these requirements or not. So before it goes to the local government, they talk about all the options. And then the last page of your compliance report basically lists the energy advisor information, the company name, the phone number, and basically that they're signing off to say, yes, this report is correct and true. I did my work. And it's the statement that says this meets the requirements of the code. Really quickly, we'll just go through the provincial report. It looks very similar, just a little bit different format. All the builder information, all the assembly information looks just a little bit different, but it's the same information in a different form. There also is a 9.36.5 compliance path on this report, where it can show they can do a different type of energy modeling than the Underguide rating on energy modeling. And then it has the same chart that shows the step code metrics, which we'll be going into. It also has a range of other information that local governments asked for. They asked for rated greenhouse gas emissions, rated greenhouse gas intensity, rated energy use intensity, peak thermal load, which used to be a step code metric and now has been removed since the December 2018 change to the code. It also lists the percentage of the building's conditioned space served by space cooling equipment. And it shows that it's more than 50%, and a range of other pieces of information about the amount of electricity and natural gas used within the home. or most of all this information the township of Langley would be receiving by asking for the Underguide reports that you're asking for. And it also says if there was an optional certification, if this home was being built to a built green level, it would just identify that as well. More for tracking purpose for local government to understand what was happening. Now we're going to really dig into the step code metrics and what they're all about. Now there's air tightness targets, equipment and systems targets, and building enclosure targets. For the mechanical energy use intensity, it's not just a static target. Step 3, you have to hit 50. There's a different change that we'll explain in a lot of detail about the size of the home. So we can see that this home is a larger home. It's greater than 2,010 square meters, and it has air conditioning. So what the target is for this home is 55. So you'd use this like a chart. How big is the home? Does it have air conditioning 50% of the home or not? And we'll explain about the air conditioning in a moment. And you'd use this like a chart and say, okay, here's your target for step 3 for the MUI. Now, when we talk about the step code metrics, it's really important to understand the house as a system concept. One element of the home impacts another. Air leakage, if you have a really leaky home, you might need a bigger heating system to make up for that heat. We see here air tightness. This is just one target. You have to meet this target. Step 1, we'll go into a bunch of examples. There is no air tightness. You could build as well a leaky home as possibly there could be, but the builder's going to have to meet just this target, percentage less than reference house. And we'll go into a lot of detail about that. So this is, at step 2, this is a sort of do or die. You have to hit this or you fail. For equipment and systems, you have 2 options at step 2. You can meet the percentage less than reference house or the MUI. Just one or the other you pass. And then there's the thermal energy demand intensity, again, which we'll explain again too. There used to be peak thermal load, which is another option. You could meet one or the other. Now you have to meet TEDI. So it's a sort of do or die on this as well. Now peak thermal load, the one that was taken out, I think they took it out because they found it was often maybe too easy to meet. And that they really, the step code wanted people to focus on the thermal energy demand intensity. And the peak thermal load was the measurement that said, does this home's heating system generate enough heat to keep it warm enough on the coldest day of the year? And so it was sort of that kind of design. Is the design heat load, is the heating system appropriate? So that we're trying to say, well, we don't want you to win on building this home by putting in a heating system that was too small and have less and pass on the mechanical energy use intensity one, but you haven't got an appropriate heating system because people are going to be cold. So that was sort of that metric was removed. So, but just going to the house as a system, many of these metrics are interrelated. For example, a super well insulated home has the capacity to put a smaller or more efficient heating system. A home that's not well insulated, you're going to have to put a larger heating system in. So what the combined metrics of the step code do is say, well, we want you to focus on the building envelope. You're forcing them to focus on the building envelope, and that then allows for a smaller heating system. Also really important is that these are energy intensity metrics. So if we look at this home for the Underguide rating, it's 81 gigajoules a year. The heated floor area is 654.3. What this means is it takes the annual energy consumption and it divides it by the heated floor area. And it comes up with a metric in kilowatt hours. Why this is important is that if we have 2 different homes and they both had an Underguide 81, we can look at the larger house and we can look at its energy intensity. It's smaller than the medium house that has the same rating. So annually they're consuming the same amount of energy, but this home is more energy efficient. Okay, so this home had to do more, had to have a better building envelope, better mechanical systems so that it achieved it in Underguide 81. Whereas in this home, if it didn't achieve it in Underguide 81, it means it was like probably less insulation in the walls or a less efficient heating system. So why this is really important, and when we go forward and look at the step code, is that also because these are energy intensity metrics, we have a very large home here, but if we had like a laneway home, it was very small, in some cases the step code can penalize those types of homes. And when we talk about mechanical use energy intensity later, we'll give some examples of that and show why they've changed the step code metrics that allows for small homes to actually have a larger mechanical energy use intensity target. What's really important with step code is understanding these are intensity metrics. It's not absolutes. This is an absolute. This home produces 81 a year. The step code is intensity metric, so it's changes. And it also shows that this home is more efficient, even though it consumes exactly the same amount of energy. So we're going to talk about air tightness, and this is one of the most critical and I think the most challenging metric to meet. And it's step 3, for this home, the target's 2.5. So what air tightness is it measures how much air leaks in or out of a building divided by the building volume. So we're talking about an hour, how much air comes in and out. So how this is done is that there's a few different metrics in there. It says air changes per hour at 50 pascals. That's what's been measured. How many times does the air change within this house within an hour? We can also measure equivalent leakage area, which basically tells us, well, we know how much air is leaking in and out, but how big are all the holes in this house when we add them all together? It allows you to give a visual of it. And why that's it's important for one, it's a metric just to measure, to know that. But two, for a builder, it's saying is great. Is this a couple big holes I have? Or is this hundreds of tiny, tiny little holes? And that's good for them to know as they're building. Is it like, have I just missed something? And I just have to fix a couple places to get there? Or is it a whole pile of little things? There's always going to be some air leakage through vents that need to be left open in various things. But what this allows us to measure is it in a different way. And then we have normal leakage area, which is the ratio of the equivalent leakage area to the surface area of the building. So if we look at this, air tightness, and this is from the HOT 2000 report, it shows it's 1.0 air changes per hour. And if we looked at the target for this, it's 2.5. So it shows that's better, it's lower. And then we have the equivalent leakage area. If we added all those holes up, it's 161 inches squared. Or the normalized leakage area is 1 inch squared per 100 foot squared. What this tells us for this home, this information also goes into the heat loss of the home. It says, well, it's going to be changed this amount of times per hour. That heat has to be replaced by the heating system. Why is air tightness testing important? Well, one, it's a performance requirement. The air tightness itself, while there's a 2.5 target, it also impacts the other targets. It impacts the percentage less than reference house, the MUI, and the TEDI. But really importantly too, the data from Lower Mainland homes, this is 1,500 homes, almost 1,600 homes in 2017, showed the median air tightness rates, the average was 3.81. If we look for row homes, tone homes, it's higher, 4.11. Now if we look at the step code target, for step 2, it's 3. So the median in 2017 would not pass step 2, which is now a requirement in Township of Langley. So it shows us that even builders that are paying attention to air leakage wouldn't be passing the step code. So really what this tells us here is that more work needs to be done working with builders to make sure that they're hitting those types of targets. A home built right, built airtight and ventilated right, has a lot of other benefits. Reduces condensation risk within the assemblies, protects the integrity of the building envelope, might allow for a smaller and more efficient heating system, reduces heat loss and gain, saves energy and reduces greenhouse gas emissions. It also helps maintain adequate indoor air quality and increases thermal and acoustic comfort. So if we look at the step code chart, as it puts in, they say required here. This isn't required in the Township of Langley, it's just the target that they were hitting here. See, this home, when we initially did the modeling for this home, there was peak thermal load. It was an option for this home. And when the initial report was put into the Township of Langley, because at peak thermal load, it allowed them to meet step 4. When peak thermal load was removed, they only hit step 3 because of the TEDI target, and we'll talk about that. But so we look at here, the maximum that this home can achieve is 2.5. So if it was 2.75, it would be a fail. This has been validated by a min construction blower door test. So what happened is, at this stage in the home, an energy advisor came, set up his blower door equipment, actually tested the air leakage, and allowed us to validate that they achieved 1.1. However, if the builder waited till the end, drywall's in, everything's done, you do an air leakage test, and then you realize you hit 3, then it becomes much more complicated to fix it. Because a lot of those air leakages are going to be sort of hidden behind drywall and all kinds of things, and it might be less fun and a lot more time and cost to actually fix those things. With builders and trades that aren't aware and thinking about airtightness, often practices were that wasn't part of that. People weren't necessarily thinking we got to maintain an airtight home. So people were doing all kinds of things, drilling, extra drill through in the hole, and then something never gets fixed. So now when builders are looking at it with their poly or whatever the approach is, any little tear or rip on the poly, now it's very carefully making sure it's patched up. In the past it'd be sort of like, oops, oh well, didn't really happen. With our colleagues at Energy Advisors that have done mid construction blower door tests with their crew, and have their crew along, they've been like, this was the most valuable thing we'd ever done, because we're not attending a course in August, but someone walks around and basically points out the areas where there's air leakage. And they'd be like, I've always been building like that forever. And pretty much probably every single home I've ever built has had air leakage there, because that's just what I did. But some of these things are very quick fixes. Others aren't as quick fixes. It's like, well, we need to really start thinking about what is our air barrier, what are on the plans. We never really had that air barrier drawn on the plans, so to that degree, and we weren't really thinking about that. We never did an air barrier over the garages. It just didn't happen. So now it's sort of being forced to think about that. Now, as I mentioned before, when this home first came in on peak thermal load, it passed to meet step 4. And it gave us another option, just like we have on MUI in there, and we'll go into those. Now, when we go into thermal energy demand intensity in a moment, air leakage is part of what makes up that metric. Air leakage also impacts this metric, which we'll go into. So this home shows that on thermal energy demand intensity, they're at their maximum requirement. This is the maximum they could go, 1.38, and if they wouldn't pass the thermal energy demand intensity. We already know at mid-construction they're 1.1, but a lot of other builders, if they were sitting right on the ledge of various things and they didn't hit a target on something, then you want to be very careful and say plan for different things to make sure you're there. So this home's fine, it's hit its target. But what this does is also lets you know where the edge case is. This is the edge case. You hit here, even though that's the requirement, you have multiple metrics to meet because this air tightness will impact this, and I'll explain that. So let's look at percentage less than reference house. So for step 3, target's 20%. So what this means is, when we looked at the Underguide rating, provides a reference rating. That means the typical new house is as if built to the National Building Code, and it's a customized comparison of each home that uses more or less energy in a typical new home, the same size, location, or design. So this basically says, here's this rating as if it was built to the National Building Code. It'd be 175 gigajoules a year. This home's built 81. Important difference, you can't look at this report like there and use that for the step code compliance because this number and this number includes the base loads. So for lighting and appliances and various things. With a step code, the percentage less than reference house for the step code takes this number and that number, and it takes out the base loads. It's made up of the space heating, water heating, building envelope, windows, insulation, air leakage, and the mechanical ventilation. In here, this particular house, percentage less than reference house without base loads, it's 62.6% better than code. What makes up the percentage less than reference house? It's everything, right? Everything on this sheet makes up your options to pass it. Space heating, ventilation, your windows, doors, skylights. So all those things are made up with here. So when we look at this, it shows you're 62.6% better. He's flying past with flying colors here. If they were not 20% better, let's just say they're 18% better or 15% better, then the energy advisor could say, well, you have every potential option to improve your percentage less than reference code. You could put in a better window, better insulation, a little bit better air sealing. You have all kinds of options to improve your percentage better than reference house. So on this particular house, it sort of beats the step 4 requirement for the step code. It's an easier to understand metric. How much better than code is this house? Well, it's 62.6 better. For the mechanical energy use intensity, here's the target for standard for homes. It's these metrics, it's steady. However, with the mechanical use intensity, there's this additional chart that shows how to know where your target is. One, this home is bigger than 210 meters squared, so you're in this column. If it was a smaller home, you'd be in a different column. And it's designed and constructed with a cooling system. So your target is past step 3, it's 55. The cooling adjustment, and we'll go into a minute, only applies for buildings with cooling for more than 50% of the conditioned area. So in this case, it's a central cooling system, a heat pump. So we know it's 50%. And we'll go into a couple examples about how you might determine that if it's a mini split, like one mini split in a townhome, for example. How do you know if it's 50%? We'll talk about that. So what mechanical energy use intensity is, it's the mechanical energy used over a year normalized by square meter, floor area, and it's in kilowatt hours. So we look at total energy consumption minus the base loads divided by the heated floor area. On your compliance report, on the first page, it does tell you the heated floor area. And it does tell you your total energy consumption. So if someone did want to do the math, you could just quickly do heated floor area without base loads divided by there, and that's going to tell you what your mechanical energy use intensity is. It's made up of your space heating, your space cooling, your fans, and your water heating. And if you had any auxiliary heating equipment, those would also be included. Again, it's mechanical energy use intensity divided by the heated floor area. In other words, in this particular home, the less mechanical equipment or the more efficient the equipment, the lower your MUI. However, because the MUI is also divided by heated floor area, the larger your home, it also impacts the MUI. If you're looking at this sheet, the things that make up MUI are your heating systems and your water heating here. So if an energy advisor sees you weren't passing on your MUI, they'd say, well, you need either a better heating system, you got to put in a heat pump, or you got a better hot water heating. There's fewer things you can do if you're not passing. So in this particular scenario, step 3 requirement, the maximum mechanical energy use intensity in the home of this size with a cooling system is 55. This home has 24. It's much lower than 55, so it's, again, passing with flying colors. So in the scenario where you said right there is, well, what happens if, again, on this scenario, if they didn't tell me what kind of heating system was there, and it changes? Well, in this case, they have lots of room to change things. If all of a sudden this heating system changed and they switched up their heating system and put in a different one, they're probably fine, because look how much leeway they have in terms of passing here. So the energy advisor and building inspector needs to know that if someone comes in and you're passing with flying colors, you're like, small changes don't actually matter or are not going to impact your ability to hit this step code metric. It's really important here, and this is why the step code change, is that MUI is just proportionally difficult for smaller homes to achieve because you have an energy number divided by size of the home. With this number, we have a MUI requirement of 24, but it's divided by a very large home. So when you divide a number by a very large number, it's easier to get a small number. But also because in the energy consumption in the MUI, it includes hot water. With this home, it needs larger heating systems to heat a larger home, but the hot water assumptions in the energy model are the same. So small home, you have the same hot water energy consumption. Large home, same number. When we divide it by a larger home, if I'm being clear here, it's harder for that small home to hit a lower MUI target. So if we have this home, right? Here's the mechanical energy usage consumption, 58 gigajoules. Because it does it in kilowatt hours, we converted those to kilowatt hours, and then we divide it by the heated floor area. It's 24. If we had the same home that was half the size, but the same energy consumption, it would be 49. This is a higher MUI than this home, again, even though it has the same energy consumption. If we had a smaller house, again, once smaller again, so 3/4 of the size, but the same energy consumption, it would fail that particular MUI target. And the intent is, this home has heating equipment for a large home. If someone built a smaller house with the same equipment, like why would they do that? It's obviously because the building envelope is probably not good enough. It would fail. So in this particular case, that home wouldn't build a home with the same mechanical equipment. It would need to build a better building envelope and have smaller heating systems. You shouldn't need the same size of heating systems that this home has for a home that's 1/4 the size. But then we have a very small home, and look, with this particular home, they reduced their energy consumption by a lot, and they pass with an 85. But look, their MUI is still way larger than this home. So when they did the step code metrics, it used to be just a static mechanical energy use target for all homes. Just hit this target. But when you see here, here's a home that has way less energy consumption, higher MUI. It's a smaller, maybe more efficient. It consumes way less energy. So this is why they went to this chart where it says the target for this home, step 3, if it was under 50 meters square, is 155. This one, it's 55. So that's why they've changed the step code metric for the MUI so that it's sort of a sliding scale based on the size of the home. And this is how you use this chart. You look at and you can double check on your chart. You can look at the heated floor area on the first page, look at the step levels required, determine whether it has a cooling system or not, and that's how you can determine what's the particular metric. And in the end message is, the smaller the home, the larger the MUI allowance, which in some senses is kind of like, it's an energy metric, it's kind of counterintuitive. Well, it's allowing this smaller home to have a larger energy consumption. Buildings designed and constructed with a cooling system of at least 50%. Now, what it's actually based on is not 50% of the conditioned space, even though it says that in the BC Energy Step Code. When they're doing the calculation, it's based on the design cooling load of the home. And why this is the case is that if you imagine this smaller home, and it's one level, 2 mini split heat pumps. Now in this it's got 2, one could assume we're not measuring and seeing if this cools 50%, because even if we were to measure 50%, how do we know this cooling system has the capacity to cool 50% of the home? And how would you know if there was just one cooling system right there, whether it was 50% of the home or not? Because, well, doors open, is this cooling 50% of the home or not? Well, who knows? But the intent of this is to say, well, we need to not have people making subjective judgments of whether or not a heating system, like a mini split system, can cool 50% of the home. So they said, well, does this heat cooling system have the capacity to cool 50% of the home? And that's what the design cooling load is. So With a central system where there's ducting coming everywhere, there's no question this cooling system's cooling 50% of the home or more than 50%. So they get the allowance. With a mini split system, they didn't want people saying, oh yeah, this cooling system in our living room and kitchen area is actually cooling 50% of the room, and you're looking at a 3-story townhouse. You're like, well, is this really cooling 50% of the home or not? Probably, who knows? And it's possible that it might be with your doors all open, but really what they've just said for this is, as long as the cooling system has the capacity to cool 50% of the home based on the design cooling load, then it gets this allowance right here. When people are using heat pumps for cooling, it's already a more efficient heating system. So you're usually gaining twice because heat pumps are very, very efficient heating systems. So you're getting the bonus kind of a couple times by putting a heat pump in a heat pump cooling system. So thermal energy demand intensity, and you'll note here, again, if we go back to here, you only had to pass one of these to pass. We saw on this particular home, they passed both of them with flying colors. So it wasn't an issue. There's no problem there. There's no passing here on the air changes per hour, not a problem to hit that. With thermal energy demand intensity, it has one metric. It's 30. It has to achieve 30 at step 3. So what is thermal energy demand intensity? It's the annual heating required for space conditioning, heating and cooling, the conditioning of ventilation air, and then it's normalized by square meter of the conditioned space. So again, your space heating demand divided by heated floor area. So then this is an intensity metric. And this also includes thermal transmitted, the heat loss and heat gain of the walls. So how much heat is lost out of the walls. The heat loss and gain through windows. So this accounts for heat loss through the windows, but it also accounts for solar heat gain. If a house with windows all across a south-facing wall, like on a mountainside or something that's just getting blasted by the sun all day, it's going to have a lot more solar heat gain than a home that's in a very shaded area by trees. So it accounts for that. It also accounts for heat recovery from exhaust ventilation, so for an HRV, and even internal gains from occupants and equipment. So it accounts for all these things in the thermal energy demand intensity. In other words, for thermal energy demand intensity, it's how much heat do we need to replace heat loss. And the more efficient the building envelope, the lower the TEDI. So it's what we see. The TEDI for a step 5 home is 15. So what's included in the TEDI? Well, it's included the HRV, air barrier again, so air leakage, windows, doors, all the insulation in the building assembly. These are the elements. If an energy advisor is working in the builder and they said they need to improve the building so they can pass on their TEDI, it's one of these things, one of these options. So when we looked at this, it shows this hit 30. It's more challenging to hit the thermal energy demand intensity target. The step code is essentially, in this case, forced them to do things. And it may be over time, I know there's conversations happening, that the TEDI is likely going to get changed in the step code. So the step code probably will, as it changed in December of 2018, it changed the mechanical energy use intensity metric, and it removed the peak thermal load, and it actually changed the thermal energy demand intensity. It's likely going to change again. This thermal energy demand intensity metric at mid-construction shows pass, no problem, as long as they don't get more than 1.38 for air leakage at the final construction stage. So we know they're not taking out any insulation or removing windows. They're good. So who does the energy modeling of various things? So essentially who can do this is energy advisors registered with Natural Resources Canada through the Underguide rating system, certified passive house designers and consultants approved by the Passive House Institute, or others using modeling software tested in accordance with the ASHRAE software. So really it can be a pretty wide range. This is what the step code says. Local governments like the Township of Langley are allowed to put other requirements in terms of who can do the modeling. What an energy advisor's job is to help the builder do the planning to meet the step code targets we were talking about. So airtightness, the TEDI, the MUI, and the percentage less than reference house. And it's sort of a consultative process. And with airtightness, it becomes a very interesting conversation. The energy advisor might look at the air barrier detail on the plans and understand the Township of Langley is only accepting, in certain cases, building permits with that air barrier there. The energy advisor in that conversation in the beginning might say, well, have you built airtight homes before? What's your best rating? They might say, well, I don't know. We've never been required to build to the step code before, so we've never done it. So they basically say, well, from the start, let's take a look at your air barrier details. Let's plan for a mid-construction blower door test so that before it's too late, we can come and fix it. And then in the end, we'll confirm it. When an energy advisor meets with someone, they basically say, airtightness is the wild card. If you've never built there, we don't know if you're going to do it. And there's all kinds of room for errors along the way. Even if you built there lots of times, you're building a different home this time. Now it's a townhome with party walls, the walls between two units that can be quite air leaky. If they were to project, you're saying is in step 1, they don't have an air tightness target. Step 2, it's 3. An energy advisor would say, well, let's just plan for 3. You're barely going to meet it. Let's not plan any better than 3, because if you miss 3, you fail. And by planning for at least hitting 3, the maximum allowable, it means they've got to build a better building envelope to make sure they get there. Now let's look at meeting step 1. There's no minimum requirement for air tightness. There's also no mechanical energy use intensity or thermal energy demand intensity target. It's only percentage better than reference house, right? And what this percentage better than reference house, 0% better, in the assumption of it is that the building needs to meet a 2.5 air changes per hour. And that's sort of in the assumption behind building code too, that homes are being built to that level. Now, if the energy advisors say they're going to get 3.5. So that would mean it's not just the prescriptive requirement minimums. They would need to do R22 effective walls or an HRV. So add one of those 2 things on. Your choice, builder. Now, if they had 4.5 and it was even less airtight, then they need to do R28 effective walls or an HRV. And they have to put better windows in. Now it's going to get 0% less than reference house. So the option, the builder then says, what do I want to do? What's the cost? Part of the intent of this is then for the builder saying is, well, am I going to do this insulation, the HRV, and the windows? Or am I going to, for this code compliant, I'm going to focus more on air tightness? Because it could be, with good planning, this could be your cheaper approach. You only have to build code compliance with insulation and windows and everything. So if they focus on the air barrier, they could do that more cost effectively than buying these better windows in the HRV, which is going to add up in cost, right? So if they're looking at the lowest cost, that air barrier might be the least costly approach. You can still pass at step 1 with 10 air changes per hour. You just have to do a whole range of different things to get 0% less than reference house and pass the step code target. So if you saw a report and it listed and it had 10 air changes per hour in step 1, but it still meets it, it still passes. So again, for meeting all the steps, but especially steps 2, 3, 4, and 5, there is no fixed recipe. Again, you get the plans, talk about the options. There's all kinds of things builders could do. And with this, the intent of is that each decision along the way or each change along the way has the potential to impact any of these. Again, if you didn't have the plans you didn't know yet with this house, here they could, they have room for a little bit of issues to happen between mid-construction and the final construction. If they have a little bit of room there. They have lots of room for changing things here, and they know their building envelope's not going to change between now, so they're completely fine. And again, the energy advisor signs off. So that's that. Now, I know there's a lot of townhomes built in the Township of Langley, and in the past there hasn't really been verified and approved by the Building and Safety Standards branch process for townhomes, and there's a couple reasons for that. One, the BC Energy Step Code requires whole building energy modeling, and there's also on attached homes, there's no requirement for an air barrier between attached units. So if you have a quad, 4-unit townhouse, there's actually no code requirement for an air barrier. The challenge has been is that when we do energy advising right now, usually we're modeling townhomes to give them an Underguide label as a unit. 4 units, we do 4 individual tests, we do 4 individual blower door tests, and we give each unit a label, an Underguide rating. But the step code doesn't allow you to do that. There's also a challenge of doing whole building blower door tests of like a townhouse unit, because you have to either have 4 blower doors or you'd have to do a range of other complicated type testing, which is difficult and maybe expensive to get right. So what's happened is there's been a little bit of gray area of what we need to do. Just as in terms of how NRCan defines this, it's not a multi-unit residential building. If you have a triplex, single stories with no overlap, that's not a multi-unit residential building. Multiple people live in that, but it's not a multi-unit residential building. So if we had, this could be a duplex or a triplex. What they call a multi-unit residential building is if this is either a 2-story triplex, this is level 1, this is level 2, but it has vertical overlap, and this is called a multi-unit residential building. So these were 2 different units, stacked townhomes, unit A, unit B, C, D, E, F. That's a multi-unit residential building. Or if this was unit A with a tiny bit of vertical overlap, unit B with a tiny bit of that's a multi-unit residential building. And it should be modeled differently. So the compliance report you have right now in your hand is mostly focused on single-family residential. And this air testing and energy modeling procedures we're talking about right now is for this. Probably most of it's like multi-story townhomes with no vertical overlaps, what you're probably seeing in the Township of Langley. The process is going to be, there's going to be an Underguide model on each unit. There's going to be a blower door test model on each unit. To help builders that might be having challenges with inter-unit leakage, the air leakage that goes between Unit A and Unit B through the party wall. They're allowing them to an extra 0.5 air changes per hour, like extra bonus allowance. So let's just say the requirement for step 3 is 2.5. The requirement now would be, like 3 for that home. And then what it's going to do for each unit, it's going to give it an energy rating for each unit, and then it's going to allow you to add it up and divide it by the whole unit. So maybe we'll go to an example here. We have 4 units. On each air change test, they have different air change ratings. 3.7, Unit 1, 3.9, Unit 2, 4.1, 3.5. As typically is the case, there's more air leakage in the middle units because it's harder to get the air barrier happening between the party walls. It allows for a 0.5 adjustment, so 3.7 becomes 3.2, and so on, for each unit. And then we take the exposed surface area of each one, we take the whole building air changes per hour, and that's basically adding up all of these as adjusted, dividing it by the surface area of all units. So each of these added up. And what it's doing is it's giving us a proxy for a whole building air leakage. And this particular unit is 3.28. For step 1, that's fine. You can still pass on step 1 with this allowance, with this particular example. And this is a sort of new procedure that's been developed for the step code for providing whole building air leakage rating or rates for a building. Similarly, for the MUI and thermal energy demand intensity, it's doing the same thing. It's giving testing for each unit to determine the energy required. There's no allowance there. It's testing for each unit. It's basically adding them all up, then divided by the heated floor area. And then it gives us a TEDI for the whole building. In this particular case, it just happens to be 30 as well. The Underguide rating system measures it in gigajoules. Step code requires it in kilowatt hours, so metric, and there's the gigajoules. The formula of turning a gigajoule into kilowatt hours is 277.78. So anyway, that's a lot of formulas. But the intent of basically is summing and averaging is how we get a whole building energy rating for the step code for townhomes. There's a few different resources that are available. There's a BC Energy Step Code website, which has a lot of different information, some for local governments, some for building inspectors. Whether or not you need to really understand all the metrics or not is debatable, but what you want to know is, here's the form I'm looking at right now, the Township of Langley Compliance Form. Do I understand what this is, and do I understand if it passes or not? As part of that, there's all kinds of, where the compliance tool is in. The Township of Langley tool isn't on there, but the provincial compliance report's on there. There's manuals. There's also a manual available for how to use the compliance report. There's also all kinds of different bulletins, like complying with step 1 of the BC Energy Step Code. Everything the Building and Safety Standards branch puts out about the BC Energy Step Code. Coming soon, there's the BOABC is putting out a BC Energy Step Code handbook for building officials. As noted, the BC Energy Compliance Reports, there is an instruction manual available for that. It's more for energy advisors, but could be of benefit to building inspectors or those that are doing quality assurance. There's a range of builder's guides that may be more or less relevant to you depending on your role that outlines the BC Energy Step Code. It talks about different wood frame construction and various things, as well as a range of illustrated guides for achieving airtight buildings. More of these are things that we're referring and talking to builders about, and the various institutions providing training to builders are really focusing on builder training about the different approaches. There's also a new resource called Better Homes BC, and this provides, it's by the province of BC. My organization, City Green, does the website, and we also host the phone call on this. And what it does, it's rebates for people renovating their home and or for building homes that we're talking about today. So there's a whole section on new construction. There is a Find an Energy Advisor search tool. So you would go in here, what type of service project you're completing, constructing a home, the Township of Langley, and it'll provide you a list. Also on this site, there's a rebate and incentive search tool. It brings up all of the programs that are available. So there's the Township of Langley incentive program. There's the Township of Langley energy evaluation rebate. There's the Township of Langley mid-construction blower door test rebate. And then it would direct you to all the information about the Township of Langley programs, the rebates you have available, and the Township of Langley website. So the website's meant to be a clearinghouse so that builders can search any given location across the province and identify what incentives are available. The Fortis program, just briefly, has different steps. There's nothing for step 1, but step 2, 3, 4, and 5. There's various levels of financial incentives available with requirements that, obviously it has to be gas, space, and water heating. That website also has what's called a quote-unquote energy coach line. So that's for builders, for renovators, but also for local governments to call to get information about various programs. So that's our presentation for today. Thank you so much for your time, and to Clay Construction for making this home available, and also to BC Hydro and Township of Langley who sponsored and put on this event.